All right, hello everybody. Day 15. So, uh, now I would like to take a couple minutes to talk about the stream in general on the channel and stuff like that. Um, Now, this is like if I do channel update videos or announcement videos, stuff like that, the viewership on those has decreased sharply. And this isn't really, if you watch this on YouTube, it's not really quite a standard channel in terms of practices, not yet at least. The stream, is pretty much everything this is about insofar, and that means that the only videos that get view time are the stream episodes. If you're on the stream, this might still be relevant. So, SIGGRAPH is in a couple of weeks, which will mark the end of the season. So there is today, tomorrow. If I will stream tomorrow, I was saying before, it's going to be super cold tomorrow morning by Sydney standards. So if my studio is too cold, I might actually not really stream. And then there's going to be a couple days next week, and then we'll wrap it up. Now, maybe you're here for these updates, maybe you don't care, but I gotta do it anyway. So probably the best decision I've made when I decided to do the streaming thing was going like, okay, I'm gonna do a pilot season. Not gonna publicize. Um, it's just gonna be to test the waters and maybe learn a little bit. And yeah, I absolutely do not regret that because the whole meta game of YouTube and streaming and doing this is like so different from anything I actually expected it to be. And at the same time, there's now that the YouTube channel is popular enough and Google Analytics, as big brother as they are, they're also super useful. Uh, I figured out, well, not really figured out, but I've learned a whole lot about what people watch and how it works out. And some of it was not surprising. Some of the math videos are between the most popular, so having those as somewhat self-contained and blackboard heavy was a good idea, it seems. They still get, like, if you look at the view curves of things, like a lot of stuff like spikes when it comes out and then tapers out and then just gets a few spikes here and there. The math videos, like, obviously spike at the beginning but stay pretty flat and well watched throughout. Um, Stuff like the callbacks video that we've done for the last, I don't know, 3 or 4 episodes, I believe, they have actually turned out pretty popular. So something I wanted to do is make them into a playlist so that they have some lasting value, because apparently there's nothing out there, at least going by the comments and some emails I received, that deals to any interesting extent with things like callbacks and script jobs and what they do and so on. Now, the funny thing about doing a stream is that the way, and that is the way I announced these, the way I always wanted to do these is basically get to a subject that is interesting for the next rigging task or subtask or detail that we need to take care of, figure out what the first principles of that might be, or what some parallel field like computer science, programming, math, whatever has to say about that, and then try and de-escalate the complexity of it until we get to some first principle that is easy enough to understand. And that seems to have gone well. It is also almost diametrically opposite to how it goes when you will be doing workshops or you will be, curating your videos and editing them and so on, where if you look at the callback videos we've done, it starts with like, hey, we have this problem, it would be nice to solve it, switching the pedals without affecting the graph, without overcomplicating things. So here's something that not a lot of people know that Maya has, or how they work at least, which is callbacks. So we do one and you go, well, to do these you need to know some OpenMaya. So all right, we'll do another stream and that's largely OpenMaya. And we keep de-escalating, and in a way, for people that follow the stream episode to episode, that works really well. For people that find these videos otherwise, they might not have an interest in the whole stretch, of how the subject of rigging was covered and did not follow the episodical aspect of all of these. It can get a little bit tough, and sometimes you almost need to swap the videos. So you either consume and digest like 4 hours of videos for the callbacks, and then in your head, you know, you practice along, and in your head you reorder things. So you might have to watch, if you know nothing about OpenMaya, you might have to watch the first 2 hours with an almost idle mind, and then finally the OpenMaya part comes in, and you can go, okay, I can move some of that back upstream, and you'll have to loop through that video in jumps a few times. So in a way, I'd like us to wrap the callback stuff, and what I'm going to do today is, which is going to be ending it because we do have a functional callback that we liked, is the last bit of first principle that applies to it, which is why would you have something like callbacks or script jobs or an evaluation graph and stuff like that? What are the differences? What are they predicated on? The irony of all of these is that like for the videos to make sense, you kind of have to watch them in the chronological order that they were streamed in, but for the notions to be ordered properly, you will have to watch them in reverse. So I suspect that people will have to do a bounce, like watch the lot to the end, and then basically start doing them again from the beginning or go in reverse, whatever. So with all of that said, basically, if you know, I'll do this playlist, and if you are watching these on YouTube and you bump into this video for whatever reason, because you look for callbacks or because somebody linked it to you, this is like the 4th or 5th part about the callbacks. I should probably have checked that before going live, but I will put it first in the actual playlist because it's probably the necessary introduction to understand why you would even do callbacks in first place. As usual, I rely on the chat to let me know if it makes sense, if the pace is right and all of that. So we're gonna do a little bit of blackboarding and possibly a little bit of pseudocode first. So script jobs, script nodes, callbacks, and so on. Now, a few things that you need to know. Actually, let's start from Maya. What you need to know, I guess, is this is a rig. We're not caring about that. Is that you have fundamentally 3 options when you want well, let's say 4 options when you want to interact with your rig. One of them is the graph, and if and when we'll do, you know, the first season proper, I think one of the first things we'll do is actually going to be to go over graph theory and how graphs work and all of that, like data graphs versus several graphs. Maya is fairly hybrid in those regards. But long story short about this is that something in Maya in the viewport basically goes, okay, I need to draw whatever piece of geometry for whatever rules there are. The whole chain of events is actually fairly convoluted and messy at times, and this is not Maya, this is software in general. I don't know the internals of this for the record, and this is not an NDA cop-out. It's like I've never seen the source code of Maya. I can assume a few things here and there which are common to all apps, but that's about it. So once that is figured out, then Maya might walk backwards through the graph and figure out, okay, I need to look at these, I need to look at these, I need to look at these, find all the, if you go backwards this way, find all the leaves of a tree, so all the very, you know, unaffected by something else nodes. And this is not how it works for the record, that's why I'm saying this is a very, very coarse, non-applicable kind of abstraction. Graphs work in a different way in practical terms. And then once it's figured out the layout of what it needs to know, that stuff is run through. Or you might look at it the other way and go, okay, you have function curves here, and they alter attributes, and that chain of events basically flags several nodes. It's called dirty flagging, and that means, okay, this node needs to be evaluated, and all of this propagates until it reaches a geometry that is drawn somewhere on the screen and then may be called or not. So basically, this is, with due exceptions, is an entirely, as far as you're concerned, stateless process. So it's a chain of functions. Sorry, just a sec. So it's a chain of functions, which means there's no, again, we're talking in the abstract, there's no real state to any of these things. something has happened, an instantaneous piece of data. If I move to this frame, that is at this frame that says these controls have moved somewhere, we'll have a chain of consequences and modify the final object, which is usually going to be geometry to be displayed. That is good for a number of things, and you know, most of rig CPU consumption is actually predicated on that. But, and we have discussed cycles and benign cycles and how to break them and stuff like that, there's a vast number of problems that are not stateless. They are stateful. Like if you wanted to roll the wheel as you travel over the ground, that is not a stateless problem. That is a stateful problem because it has a time component. So, and my tablet drivers have crapped themselves again, so this is going to be interesting. So if something needs to roll on the ground, you have speed and acceleration. Oh man, this is going to be brutal. You have speed and acceleration, and what that is basically a function of how much distance, and you can put it in either, you know, in either direction, but how much distance have I traveled over time, right? So without an actual time component, you can't really know the speed of that item and how many times it rolled, because that rolled over a circle. You know, if you take your wheel circle and you figure out pi by 2, you know, you might end up here and here. So without that time component, you cannot know the distance, and you cannot know that, you know, at this point here, this thing has rolled twice. Now, in a similar fashion, sometimes you want something to be done once, and that's it. This has no notion whatsoever of a state. It can't go, okay, let me save this item and then I'll look back to it, and if this item has been set or it has these qualities, then I'm going to do something else. Which is what we were showing in, I believe, the first video on callbacks. And anyway, if you look at the description in the video, or if you've been following, if you look at the page where when that video was posted, there's that example, and I did that offline just so that people would have something to play with, at a reciprocal translation example where you could move one object and another will follow, and then move the other object and the first one will follow, which if you do the graph will be circular and not applicable, like, or rather not implementable, unless you add states, and it can get pretty messy and ugly. So, and that is what we decided to solve with callbacks. At the same time, and in one of the videos I briefly lied, and then I think I corrected it in the following video. I was saying, yeah, sure, your callback. I don't know why I was thinking that, because we don't do that at work, I don't do it at home, or probably because I don't deal with these things without a framework. I was confused, but when you implement the callback, it's going to get attached to an object, which will basically have added functionality predicated on some events running, but that is for the duration of that session. So if you close that scene and reopen it, it's gone. Not ideal. And you also have to bear in mind that that callback will only fire when that attribute is changed in manipulation mode, let's call it, when the attribute is changed, like because you punched the new value here and so on. If you were actually animating the value and scrolling here, that callback will not get fired. So the documentation on this stuff is sketchy at best, and I've made that point before. The documentation is actually pretty decent, fairly complete, if you know what you're looking for, which is the issue with almost all API and technical dockers, to be honest. If you need to program for Windows and you look at MSDN, it's like it's a vast ocean of pain unless you know exactly what you're looking for. So what we're trying to do is not so much teach you how to implement the specific callback and all the methods in the API. It's showing you, okay, this is the map of what you should be looking for. Now go home and practice, right? So there is a lot of rambling, but I wanted to get out of the way the context of all of these and why we are just about to do blackboarding on how applications run. So here's the other meta content, so the content about the content. When I was talking about, well, when I wrote about what I wanted to do with the stream, I say this is about first principles, and in rigging, several things come together. So you need to be really good at it. To be honest, you need to be a master of many crafts. It's like jack of all the trades, master of none. Yeah, it's only going to get you so far if you want to get really good. There's quite a few things where you don't need to become an absolute domain expert, but where you need to get pretty good at what you're doing and seeing the connections between all those things. So tinkering at some point has to evolve into proper engineering, like system engineering. That is largely what rigging is about, at least in my book. Other people might disagree, and if you're interviewing with those other people, you know, tell them whatever they want to hear. Now, one of the things that I wanted to do in terms of like this whole notion of escalating to needs and then de-escalating to learning the basics is computer science and software design. There's often some very, very simple things that for some reason are so overcomplicated that they never get taught, or they're taught into these borderline mystic terms. You know, design patterns is one of those things where there's these holy books of do it this way and don't think about it because it's really complex and you can't understand it. And normally I don't swear on stream, but that is just so much horseshit. So, sorry if you have kids listening and these on speakers. Here's how applications work, and it's like this has been true at the very least for C on Unix. So Dennis Ritchie times and the Bell Labs in the 70s, something like that. Almost all applications are internally, well, at least in C, which is the staggering majority of the native code that you're actually going to run, pretty much start with something like this. And there might be arguments for the command line. So whenever this is C syntax, but I mean, it shouldn't be particularly hard to understand. There is going to be a function that's going to be equal main, or if you're writing windowable executable on Windows, you're going to be having winmain, I believe. I don't remember if it's capital or not. I think it's lowercase w, but don't quote me on it. And when you run an executable, the part that actually the process runner, if you want, in the operating system expects to find this signature and to call it after having given it a few resources, and off you go. That's your application. That's pretty much all that happens. It's if you wanted to write a compiler with absolutely minimal support for just one operating system, you will get away with just compiler and assembler with just a few hundred lines for the law. You would have very, very little to implement. Now, the next thing that happens, if you do this, so, and if you're not familiar with it, this has become a nightmare over the years, but it made perfect sense in the 70s. 0, which is actually false if you look at it in Boolean terms, it means everything went to right. Any other number which is true means, okay, there's been some accident of some sorts, here's the code for that. And that's because success is, a unique state, so you only need one number for it, and then many, many numbers, which is anything non-zero, is for all accidents. Now, in practically every application, you will have something like, and I'm not saying it's normally done this way, but you would have something like this, and then a while loop that will go something like this. And at this point, this is, possibly using PyCharm was not the best idea for this. Let me see if I can pick up Notepad. And all right, this might be a little bit better. And at this point, this is an infinite loop, and this is how a lot of applications really work. And in here, something is going to be catching your keyboard, so there might be some device object, of sorts, and this is not how you will find in an API, but using PyCharm is always the best idea. No, not for writing C-like code, it's not the best idea. CLI might see through that, but CMake is a project. Anyway, so you might have something like that. I'm not going to start writing pseudocode for everything here, but you know, you get the idea, I guess. So, and here you might have some constant call, you know, main keyboard or whatever. So a lot of stuff works like this, and this infinite loop at some point will go and break out of it when something has happened that means a quit or an error and so on. So sorry, let's say that in here, every time this loop runs, you go, okay, again, pseudocode, luckily, no actual system API works like this. You would have if, you know, keyboard key pressed equals, let's say this is absolutely horrifying, return strings that you have to parse. You know, if somebody has pressed control quit, then yeah, this hybrid Python C word, I'm confusing myself at this point. So then you will break out of the while loop, you will get here, and you will exit. So if this seems overly simplistic, it's not. This is at the very core of most applications. This is the outermost loop, and that's pretty much all that goes on. There are more complex systems than these that are built on top of frameworks, and some of those frameworks are aligned to your system. So especially if you write on macOS with any of their stuff that's bound to their own APIs, you know, you'll find that these things can change and get richer. If you use Windows, you have a lot of macros in there, like WinAPI and the callback macro and all the wrappers for everything. But under the hood, eventually, this is what it boils down to. So, with that out of the way, now inside this loop, you have many possible states in an actual application, and this is the case for Maya, and this is probably what you are interested in when you make decisions on what to use. So Maya has a main event loop, right? And we're not talking about Maya batch, which will change the dynamics a little bit because it will miss some of the parts of these loops. I really want my tablet drivers back. This is going to be so hard. Anyway, so Maya starts, and then you have the main event loop. This is our Maya process. There's a bunch of things going on with paging memory, accessing resources. It doesn't really matter. Now in here, and again, I'm oversimplifying. In this loop, Maya might have something like evaluate attributes. Then based on that evaluate attributes in there, it might choose to call something like check if the graph is dirty. What am I doing here? So, you know, check if the graph is dirty. So dirtiness, but you get the idea. And, you know, if that is true, then you have a bifurcation here. If it's true, you know, you might have refresh the graph or run the graph or eval the graph. And if it's false, you're just going to be moving on. So it really is, by the way, under the hood, there's a lot of complexity coming from all the stuff that needs to be done, but very often the abstract of it is that simple. So once that graph is done evaluating, and this is not necessarily the right order of things, there might be something like view refresh. And once that is done, until something else happens, Maya might choose to enter an idle cycle. And I'm not going to start expanding this a million times, but hopefully you can see where this is going. So maybe before that eval attribute, there is something like evaluate devices or fetch devices or stuff like that. So you would have something like fetch device state, and that might be, you know, your keyboard. It might be hardware drive, well, not hardware drivers, but hardware node that you wrote, which you can do if you want to support some exotic controller in Maya. You can actually write your own devices for it. And this is pretty important because this gives you some vision of what is going on inside Maya world. So you clearly have stages where you go, okay, there's a phase where I'm evaluating the attribute. There's a phase that is probably going to be the most CPU hungry, that might or might not exist because there might not or might not be dirt, that actually evaluates the rig itself. Then there's going to be a UI component, so something like that, and then Maya is going to enter some idle state. And one of the parts that Maya does actually quite alright compared to some other applications, and it's done it for a long time, and ages ago was one of the reasons for its success as a pipeline tool, despite its faults somewhere else possibly, is that it always gave you some control or at least some vision over these things and a way to exploit them. So, and this is why it's important to know that you have these stages, and it's important that you understand how the various stages are manipulated, because all of these are affected by different things. So this is literally your rig. If you wanted to do something at the view time, this would probably be a mix of shapes and shaders and stuff like that. If you wanted to do something at evaluator time, this is where, in example, you would have the callbacks. Now, what happens is that you also have to look at the Maya state. So if Maya is in a state where you are, and let's see how this is going to go. So if Maya is in a state where you are manipulating something, it is very possible that this rig thingy, and this is actually the case if you use parallel evaluation, it might run in digi mode, and or it might run in parallel mode. And they actually have some key differences between them. So if you are in this state where you are manipulating Maya, you're at manip stage, you are, unless you have something very recent in 2017, which is the new control tags, you're going to be running your attributes evaluation. You're going to be running the rig in digi mode only, which comes with its own set of rules. You are probably going to be refreshing the view, so you do have something like that, all the shaders and stuff like that. So this is the view implementations. Definitely not going to have that unless you have controls. And you are going to enter an idle cycle very, very often. So in programming, and this is one of those things that I think is often overlooked, unless you're in games, where in games this is very well understood. As humans, we tend to think of things as continuous, but almost everything has a beat. So in games, you need to respect the beat of the refresh of your monitor, so you might choose to shoot, you're on PlayStation and you're on crappy TVs and you're doing more than the hardware can cope with. You might choose to try and hit a steady 30 frames per second. You're going to have 33 milliseconds for every frame. You're on PC, most monitors are 60 Hz, and you want to please the PC master race, so you're going to try to shoot for at least 60 Hz, which means you're going to try and run a frame in 60 milliseconds. You choose to please, all the hardware enthusiasts and go for unlimited frame rate. You're going to try and fit everything in 1 millisecond. So, but what is important is that there is a beat. And if you play games, if you play Call of Duty or something like that, very often you'll see discussions in the wannabe pro gamers communities or in between pro gamers of like, oh, it scans in frames. So if you run 100 frames per second, your bullet scan is better. And that is because in that game, maybe this loop is tied to the actual frame rate because it's a fixed frame rate function, and the hit scan for the weapons is inside that loop. Some other games might actually run separate threads. So the faster your PC, the more hit scan checks you have, the more precise you're going to have. And it's the same for Maya. So if you're manipulation mode, you're going to frequently actually hit an idle cycle. If you are, however, in playback mode, I hope this is interesting because this is a lot of blackboarding and abstract, but it's one of those things that even after years of programming, it actually took me quite a while to come to these realizations. And it's like, and they made a huge difference. Now, it's very possible that at this point, the attribute callbacks, as you know them, so let's say that we have two modalities for this, and this was attribute change. You're in parallel mode, this just does not happen. What you have is only attribute animation. So only things that have a function curve or have been flagged in some ways in the graph will actually be accounted for. You don't have a DG mode at all, but you have a parallel mode that's running. And sure, you will most likely have view calls all the time. And you're definitely not going to have an idle. So, and this is one of the reasons why, and there might be intricacies inside Maya which I wouldn't be aware of without looking at the source code, like maybe the callbacks are actually deferred to the idle, maybe not, maybe they have their own special place. But this is why you need to understand at least a little bit of how applications work and the fact that they're just loops and several loops managed or loops with stacks and queues and things like that. But ultimately, this is what determines where you implement things. So, and this brings us back to what we're saying here. If I want something, you know, if this is being keyframe going around like this, and I want that behavior, I need to make sure that it's actually implemented when I play back. And for the record, when you scrub the timeline, it's actually playback events, many playback events fired. And I need to make sure that I don't have anything that's determinant, so that will actually do something that I rely on that's in the idle cycle. Not going to go into the whole determinism and side effects and non-deterministic and out of order. Like, not going to do that just yet. But it is important that you do that. Similarly, very often, and this is why we did the whole callbacks thing, very often animators ask for something that, if done, no drivers, if done inside the rig, like this, you know, match my FK to the IK and the IK to the FK, will be a cycle. So this is just not suited to do it. And you also want to affect the animation with it. Like right now we have a very simple code that if we add keyframes on this will not be working great, but we're not going to take, you know, another 2 hours detour into OMC just to show how to deal with function curves. So it's cyclic, it's nasty, it will cost the rig a fortune to solve, but you could actually fix it, like you could actually implement it for the record, maybe even without custom nodes, maybe, but it should not be sorted out. It should not be sorted out there, because in terms of context, when the animator is playing here, he's not manipulating at the same time. When you're playing, actually, Maya will not let you manipulate things unless you're doing dynamics and you have live manipulators and something like that. It's not the context that animators work in. So you are not interested in the rig context at all anyway. But you are interested in the attribute change, and you have to make sure that whatever you do in that callback has an effect. So, and again, that's why I was saying, you know, if it has function curves, you have to go in and key them. Has an effect on what will eventually inform the rig at playback time. Now, there is, when you think about it, this is the inner loop of your rig. So this is, well, sorry, actually, this is the outermost loop of your rig. So when Maya gets to your rig, you will be, you know, in a sequence going over these things. But there's another part that is pretty important, and this is going back to the lie that I told, that callbacks will load with your scene. So if your rig has its own loop, we're not constraining between rigs, we're not dealing with cross-scene trickiness or anything like that. Now you have, you know, your sequence of events, these are all the things that you implemented. There is also a case of going, okay, there's an implementation that I need for manipulation. That is my callback. You know, how do I bring it in? It's like you can't ask an animator to run a script every time they load the scene. I mean, if you were in a quick commercial where, you know, you only have 2 days to do something and you're repurposing a rig, sure, that might actually even be an option. You know, it happens. It's a small shop. Somebody gives a script to somebody else by email or by sharing it somewhere and goes like, look, run these please every time you open the scene. But if you were to actually deliver that to more people, there is another part to that rig, which is when it's actually consumed as an asset. So there's the asset component of that rig. Now that asset has its own life cycle, and that might not be a loop. In fact, it rarely is, but it does have stages. So that asset, will be eventually saved. It will be eventually published, and this is the part of things where normally pipelines come in. It's not something that you can. Maya doesn't have and doesn't need to have facilities for these one-to-one, because every place, every person is different in these regards. But you have a consuming state for that, which is when the rig is getting consumed, which is it might be imported in the scene. And how does it get imported, right? Does it get imported as a reference? Do you load the scene? It's manipulated. Then at some point, it probably, so we were saying it's manipulated, it's played back. And then at some point, it is also expected to produce data. So the outcome of all of these is that it should actually produce animation, right? That's the whole point. And then that cycle in itself will need to go through, save and then load, which brings you back to probably, oh come on, somewhere around here, possibly right after the import. I am struggling if it's not obvious. Yeah, so somewhere after the import. So you do have these loops that have a bit when you work with applications. These things have this constant bit to them, and if you know where to hook into that bit, you can do great things. Some things have an erratic bit where some callbacks are only run at a certain time, and some things have a very, very slow kind of heartbeat to the life of the asset, but it is super important. So it's a long talk to basically not really conclude anything just yet. But I think it's a very important concept to keep in mind, because when you're trying to solve a problem, which rigging is software design, at least, if you're following this trend, this is probably the only thing that I ask people buy into. There's no difference between rigging and doing software design and software development. Most of rigging, at least. And it is important that you learn to look at problems this way. It's like your rig isn't, you don't save your rig and you're done. Your rig is a consumer stage that you need to take care of. And sometimes pipeline engineers will do it. Sometimes, you have animTDs that develop tools. So your rig might actually be consumed in different ways. This is the way an animator, this is the consumption stage for an animator, right? But an animTD might actually want to consume your rig, as in be able to inspect it and so on, and they might have completely different requirements. Like they might actually only care about inspecting it. So something like, I want to get all the controls, and I want to get everything that is not a control, so that if I find it and I have to figure out if I have to key it with this magic tool I've wrote, I know not to do it, blacklisting, whitelisting, stuff like that. So in many ways, your rig, your interfaces, and the tools that you deploy and stuff like that needs to be able to have different faces. Sorry, really scratchy throat today. It needs to have different facets to how it's consumed, and some of it might be done with APIs, some of it might be done in Maya. So for now, we are gonna be focusing on that. All right, not super bad. It only took me like 30 minutes of rambling to go through these. So know your tools. Next thing is, what do you have in Maya to do that? Obviously, you have the rig, which is gonna be stateless and supposed to be very fast, because it has to be evaluated as many times as your frame rate beat, which for movies is 24 frames and so on is, and all that crap, right? And bear in mind, you might need multiple rigs running real time, and you might have a stage, the set cache or whatever. Now, the other thing that you do have a hand, which we've seen, is callbacks. So, and this is super small tangent in this case, I swear. I've said several times, it's like one thing I really dislike is software myths. Like at some point you hear, oh, my expressions are slow, oh, my expressions are good, constraints are slow, constraints are good. And all these legends about how software works are born, and because people often don't look deep enough into the technical side of things, you buy into superstitions. And some of these things change over time. Like maybe at one point they were actually really, something was really slow and you should have avoided it at all costs, and then it was fine. So the usual myth of like, the two I've discussed is like, oh, namespaces are bad and multiple shapes under a transform are bad. No, they're not. I know how these myths came into place, but no, they're not bad if you know the context you're using them in. So before I start another software myth of that kind, I say, script jobs are like the annoying kid in the backseat that keeps going like, are we there yet? Are we there yet? That I don't want people to completely ignore script jobs because I say that, because there's many types of script jobs, and some of them are pretty useful. The annoying kid in the back is doing a selection script job, which I really don't like, but it might even have its places if you install it really late. So not in this context. I don't want one in the way when I'm doing this, but again, it's important that you understand when and how things are consumed by whom, because maybe in lighting, script jobs are fine. Maybe they only use caches and their entire selection is predicated on 10 possibilities. It might actually be fine. Not for us, we're gonna ignore script jobs for selections, but there are other callbacks, and there are called callbacks in both cases, that you can implement in a script job, which are actually useful. And the last one is script nodes. So script nodes is actually what I am going to look at next for the implementation. And the important thing to understand here is always the context of each, right? So the rig, the rig itself is basically the scene. Whether you import it as a reference or whether you load it as a scene, this is pretty much, going to be the king of data in a way. Now, when do callbacks happen? Callbacks do require a scene, so they're predicated on the rig existing and you being able to trace items that are in it to attach to, and callbacks are per session. So that's one of the qualities of callbacks, like the ones we've seen at least, which is, I should specify here, we're talking about message and node message callbacks especially. You also have scene callbacks, which are very akin to script jobs in some cases. So they are per session. They can be tied to individual items, which is the part that we like. So they can be per item. So they will, let's say that they're per node. This is not the whole truth. This is the subset of the truth that we're interested in. They can be other things as well. They do not run on playback, and that is, like when you say something, oh, this does not do that, it sounds like a negative. It's important that this part is understood, because sometimes being able to have different behaviors between manipulation and playback is what you actually want. So don't run on playback is actually a feature in this case. If you needed them to run on playback, you will be using something else. Now, I'm going to stop at that because those are the qualities we're interested in, but script jobs. Script jobs are not predicated on the scene. They come into their own. And they do not need to attach to any object specifically. You can implement various types of script jobs. You can implement on selection, which is the nasty one that I was talking about. Did I open the tab? Probably not. No, I didn't. So let's actually have a look at it. So script job command should actually be the extensive West. We're in luck here. So this is the actual, it says it's a Python command. You probably find that most of the examples are in Mail, but this is what it can do. This is what the command itself can do. Exists, conditions, what event you want to run on, and so on. And here you have list events, which actually serves as your list of what you can implement as well, and it tells you the angular tolerance change, and it's there's a lot of stuff where you go, okay, somebody probably at Autodesk or some specific client needed something very specific, and they implemented a new callback to do it. But some of these are actually quite useful. And found new occurs in example. Like these will actually, if you install a script jobs that says I'm implementing delete all, when somebody does file new, before the new file is actually, so before the scene is cleared out, you can do something. So you can do a tear down. You know, you import stuff that's your build up. If you want to make sure that when the user closes the scene, you save some nuggets of data that are here and there. You don't want to, you don't trust the user to just go, oh, save these as a separate command. You want to make sure that whenever they save the scene or when they exit the scene, you always save that last state. You could do it by doing a delete all implementation, in example. And it goes on. So I'm not going to read all of them, but hopefully you get what this means. And there's stuff, and that's kind of it's something that can get ugly, but it's sometimes useful. You can even hook into the UI, which when everything with smell and just smell is pretty powerful, nowadays can be a bit dodgy. So script jobs are also per section. They don't get saved. And that is because they have no node presence in the graph. They have no data presence anywhere in the scene. And Maya doesn't really do, like Maya is very, very graph centric. The Maya graph is both the data graph and the eval graph in most cases. And scenes are often a long list of macro-like manipulations of that graph, for the record. So they're per session. They can, we say here this is per node. They can be attached to a node. In this case, this is not true. They're entirely per event. So they're entirely driven by what event will trigger them. Are they? Yeah, I think so. But there might be some there might be some special ones with some edge cases, so don't take these for the absolute truth. Go and check yourself. Definitely don't run on playback. But we say that we have a problem, which is we want people to load the rig, load the scene that rig is provided in. And again, if you're using references, like make sure that you understand what events fire when and stuff like that. There's slight differences, and you have some will not be run, some load scene events might not be run, whereas all the additional reference events will be run, which gives you fine-grained scene manipulation in a way for ingestion and stuff like that. Now, script nodes are, I find them personally pretty interesting, because script nodes, unlike, so they're not necessarily predicated on the scene, but if you really want to, they can kind of be, because they're actually a node. So there will be cookies and milk. Huh. There might be cookies and milk, though I'm not sure of the, I love cookies and milk, but I'm not sure of the context in this specific case. So script nodes are somewhat special, because unlike everything else, they are actually per scene. They can also be per session. You can have things like run once, and as in they only run once, and you can make things permanent or not. Well, this is true for script jobs as well. You can make a script job permanent, or you can make it volatile. So there's a bunch of things. But as far as we're concerned, this is the interesting bit. They're per scene, so they will go with the scene, which is great. They are per event, so you can choose what you implement, and they have a reduced set of events, but they manage them in a particular way, which is for each event, and this is kind of cool. No, it's actually pretty cool. I mean, it's good that it's there. It'd be very hard to do certain things without this. They can also choose to run before and after, so you can do some fairly complex stuff by interleaving the right script nodes and the right callbacks. And they, for the most part, they don't run on playback. I think none of them run on playback, actually. I would have to check again. Not the absolute truth. But remember, we're talking about what we're interested in. We're trying to solve a specific problem, which is I want my callback to run when I import the rig. And this might be something that we do tomorrow, because I've been doing the blackboarding session for a while now. But so this is how you look at solving a problem. So if I didn't know about, and there's been a time, obviously, you know, I wasn't born knowing all the 3D apps I've actually had to deal with, some of them in spite. Um, it doesn't matter that you don't know an application. You can find whether it's suitable for what you need or not if you know what you're actually looking for by breaking down a problem with like what kind of loop is that problem need to be solved in. So if I was using some other application, not going to name names because I don't know if they implement some things or not, that does not have callbacks at all they have is the instantaneous rig evaluation. You can solve some of the malicious cycle problems that you can solve with a mix of callbacks and other things. Maybe those applications actually implement something else, so you might want to go and scour the documentation to see if they have some, magic message pumping or message queuing system, or if they actually allow for stateful nodes and stuff like that. There might be a mechanic in there. There might also not be. So don't try to solve problems that you cannot solve, right? And if you know what to look for, then eventually, even in a new application, if you're new to Maya, if you're new to Maya, you don't know all of these details. Again, that was the case for me at some point. You just go and look for the things that you know you want to do. You need to use. So you go and look for something that persists with the scene. You file script jobs, do they? Nah. Callbacks, no. A rig, it's like, could do a custom node. It's like there used to be a bunch of things you could do before parallel that were dirty but super powerful. Not the case anymore. And then you find script nodes and you get. So, what was there? There was 50 minutes of rambling about it, but I wanted to get this out of the way. Okay, one last note, because I think this is pretty important. We're not going to use it now, but the existence of the idle cycle is often overlooked and extremely important. So very often, if you have something that runs, it has a pretty hefty running cost. So even a callback, as people manipulate, if that callback is expensive and it fires a lot, and maybe it doesn't need to fire quite that much, it might, this is the manipulation graph. It has a bit. As people move a control in here, the responsiveness of these, that's your bit. If I can do whatever this manipulation is at 500 frames per second, the user is always going to have a smooth manipulation experience. If this fires a callback that takes half a second to run, depending on when when Maya will actually do the polling of my mouse and manipulators and so on, it might get really stuttery. It's one of those things where you go and you see it going like kunk, 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 because there's something that the mouse or the devices or the viewport seeing for those. Maybe that's that's got a 500 hertz tick. Every half a millisecond, it's pinging the devices and go, what's your state? As the mouse moves, as the mouse done that, and it will receive that in a fraction of a second. But then within that loop, it needs to run this callback, and that loop is often single-threaded. That is really expensive. So between those events, you get this stuttery tuk kind of motion, which is horrible. And that may be because it doesn't run at playback. Your rig will play back at 200 frames per second, but manipulating it is absolutely miserable. Now, again, a long rambling part just to say that you have an idle call, and Maya, when it's kind of gone, okay, I seem to have exhausted all the other steps in the loop that I'm running that are critical, it will enter an idle state. And if you not going to go too far into that because we don't have the problem to solve, and I don't want to show things that I don't have a problem to show them on. But there's something called evil deferred, which if you're doing UI work and you have an expensive UI on the side that you want to sync with Maya, that's a classic example. You don't want to refresh that UI with callbacks every time something is being manipulated. You could have the callbacks actually, queuing up stuff, but consuming that queue to actually update the UI, which is maybe not something that the user cares about. They're looking at the screen with the viewport while they're doing this. The UI is sitting somewhere on the side. you defer the evaluation of all those things. You have this big queue of things that needs to happen as soon as the user stops manipulating. You put that in the idle cycle so that this part will run many times. This part might run at 500 hertz, 500 frames per second if you want, and only by the time it's done with the manipulation cycle, however many loops of these it actually took to do it, then it will run these just the once. All right, with all of that out of the way, how tricky is it to get a script not going? Not at all. So hopefully this was worth it, because I think this was, in a way, for me at least, the missing bit of why I'm showing all these things. Oh, come on. So I don't have middle click or right click, so I'm really struggling. I'm doing about half the things with the mouse and half the things with the pen. So if you want a script node, all you need to do is get one. Now, this is the part that's interesting. Hopefully, UI might be a little bit tough. This might be because of the resolution. It might be super tiny, but we can zoom in here. So this is pretty important. You have the script type. These are the attributes you have. Out of order as usual. I think they're alphabetical in this case, which is useless. So in the script type, you have demand, open, close, GUI, open, close, UI configuration, internal, which honestly I don't know what it is, software render and software frame render, same configuration, internal, and time changed. Now, you can implement open, close, which is the very interesting part. So you can choose what type of language you want, so Mel or Python. Now, the part that drives me insane, but you can still set this stuff, is here in the after or before part. These are messages, right? Which, well, they appear as messages, but strings have the same appearance. Like, these are basically string fields, is what I'm trying to say. Now, do I have a Mel? Yes. So in here, you can actually put whatever you want. And if I have set, these get saved with the scene. If I have set these to do something at open, close, before, and after, and that might be what installs my callback, whatever strings are in here, it will do just that. And that string can, for the record, include eval deferred. So the script will run on scene open, but only once the graph is fully assembled and run and all of that. If you want to run as after as possible, it will only kick in at the first idle cycle that Maya makes available. So syntax for that, I mean, you could do it in Python, find the attribute and all of that, but I haven't done this in a long time. So set after, this might be a train wreck, or it might actually work fine. So that would be, I am quite positive that it's lowercase. Then the type for string is one of those things that drives me insane, because I think type for string is special because string is actually a keyword in mouse, so the type needs to be a string itself. That's like, yeah. And actually, let us, what do we want to punch in there? So the value, yeah, you can just put the value in there. So the value needs to be of type string. Now, you want to print the string, so that needs to have quotes in it, which, to be real quotes, need to be escaped. That's a Mel thing. That's actually a lot of languages thing. So if I escape these quotes, they're actually going to be seen as quotes in the string content itself, which Maya will try to run. Print, what do we print? All right, let's be incredibly cheesy and programmery. So will this work? Will it not work? Also, I believe that it will not give you a new line. Well, okay. I don't trust things that work first. Oh, yeah, we set it to Python. So Python and Mel, this will be the same thing. So, again, node with a presence in the scene. Let me save it as another version in case these nukes my scene, which it really shouldn't. So that's been saved. Now the expectation is that when I open that, I will get that message. Did I get the message while scanning string literal? Oh, okay. I bet you that that's our node actually doing that. Come on. So, but there should be a script node in here. Yep. So let's have a look. Oh, sorry. I was like wondering why things didn't work. Arrow while scanning string literal. Result untitled. That's probably the result of that, actually. Now, the part I'm not 100% sure about is not liking the end here. Should be fine, but sure, let's try without it. Oh, it was actually... Let's have a super quick try at that. There you go. So, it's super tiny, isn't it? Now, that has saved with the scene, so it can implement whatever you want. It will only run once after the scene has been opened. So for the record, you can actually implement both before and after in the same node. I'm quite positive about it because I remember using it not too long ago. Which means you can, when that scene is loaded, you know that scene is consumed, you are in control of that scene, or like you know exactly that some contents in it are guaranteed because they're uniquely referenced and lock nodes and all of that. You can say, provided you lock this node as well, so the user can't delete your script node. You can go, okay, whenever this scene is consumed, I want this to happen before the whole evaluation runs, which might be pre-fly, where you go, okay, I'm gonna set all these parameters that the scene requires to exist, because Maya will save a lot of parameters per session and not per scene, and you want to work per scene. And then you go, okay, by the end of it, in here, I'm gonna have a very long string, and for the record, I've had strings in Maya that were like 10 megs worth of text. It's perfectly fine. That's another myth I've heard. Oh, you can't have a long string in Maya. No, that is just so much horse crap. I have literally had 10.8 megs worth of text in a string just 2 days ago. And it was just fine. And then you can put whatever you want. So all of the work that we're doing here to remove the existing callbacks, which if this is on your scene, we probably don't care for it, to install callbacks, to inspect things, to make sure that these things exist in a certain scope because we want to use those function calls. All you have to do is pretty much go, and I'm not going to do that now, but you will get the idea, I hope. Put them in a triple quotes, and then go, my executable, or it's not that executable at all, but will be okay. And you set your attribute to that value, and that is it. So somebody's saying we had a problem on a previous film where extremely long strings will get truncated on file save unless the attribute was locked. Not sure if that still is an issue or not. So I have heard that. I have had very long string problems, so check how it works out. I don't know what extremely long strings will be in your case. I know people who have taken the bytecode version of a binary alembic, converted it to a string that could be re-encoded back, and then actually deserialize back to the ABC binary and generate that as a shape node inside mine, stuff like that. And they were complaining that it was a bit flaky, and in that case it was a 295 megs worth of text, and they had huge problems with it. 32,000 characters is not a lot. I've had strings like 10.8 megs worth of Unicode text. I mean, I don't want to do the maths, but it's a lot more than that. So test it, and I'm talking about my 2016.5 and 2017. I know for sure because I've serialized ungodly strings in those. Well, for me, 10 megs worth of characters it qualifies as unholy, if not ungodly. And that was fine. But yeah, check that it doesn't have issues for you. It might have been 2 to the power of 32 characters. Yeah, that's so. Still not really a ton, to be honest. Anyway, unless it was a factorial 32, in which case it will be running out of memory. So, this was just over an hour, and I know we have not, really done anything to the scene itself. But I wanted this intro to why we look at callbacks and script jobs and stuff like that out of the way. So tomorrow, with this knowledge, which is, okay, so if you're following the stream or you're following the archives on YouTube in chronological order, next video, tomorrow, chronological next video, we're finally gonna finish this callback saga, which I don't know. I think it was worth doing, and looking at the YouTube analytics, it appears that a lot of people found it from outside, and people that don't consume the rest of the stream were quite happy to go through it. But if you are actually looking at the callbacks playlist, I really want these to head that playlist. So the next video you'll find in the playlist will be the first time we actually did callbacks in the stream. And what I will be doing tomorrow, you'll probably find at the very end of it, because it's the final stage of deployment. So, all right, this was a lot of talking in Blackboard, but I got it out of the way, and it's something that is very dear to me, that people understand there's no magic to software. It's like, don't treat Maya or whatever other software you use like it's some magical piece of black box technology that you cannot understand. It's, what is it? It's turtles all the way down. It's like, it's while loops all the way down. That's all that's happening. And devil is in details, It's not like it's trivial to write the loop for something like Maya, because in here you're unlikely to have something like that. This actual loop might be running several functions, let's say fetch devices, and then it might actually push that fetch devices to some queue, so whatever, they might have their central system, something like that. So and some people do NQ, some people do NQ, as in don't know which is correct. Not an English speaking person, so they might have something like that, and then they might go, dispatcher .NQ. After you fetch all the devices, they might want to marshal the attribute calls so that they do things in one go. And it's like, and when you expand these things, like when you look at what they might be doing there might be quite a few tricky bits. They might have some, global or global-like storage, where these things are ordered for ideal performance. And it's like, what you do in an actual C application or a C++ application, when you do an application from scratch, and that's why I think it's important. So another tangent, but bear with me. That's why I think it's important that people learn languages like C or C++ or something like that, and do applications from scratch at some point. Python is alright if you want to learn the basics of programming, and it's actually alright even on the other end, where you do some very you can build very complex systems in Python. The part that it misses is it doesn't allow you to gain an understanding or experiment with what goes on at the actual ground level of your application. It's just not suited to do very intensive cycles. It's just not suited to having things like complex queues. And anyway, sorry, that's going off a tangent that I want to go off on, but it boils down to that. Know what the loop of the application is, and again, I don't know my source code. It might be running something completely different under the hood. Looking at my CPU graphs, it's certainly heavily single-threaded, and for the record, a lot of these loops are just not very easy to multi-thread, and very often they can't really be multi-threaded in first place, or not extensively. But that's for another day. Do understand, there's no magic to it. All that you care about is knowing what sequence of events runs and what parts of it you can exploit. Alright, somebody actually did do the maths. It was like, you have strings that are 4.2 billion characters long, they deserve to get truncated. Look, if there is a limit to that string, it might simply be some power of 2. It might be, 2 to the power of 32 will be, is that 32 bit? That's, yeah, you maybe might be exceeding the byte count at that point. Yeah, I should have seen that, because it's like you were saying, oh, that's to the power of 32. That's 32 bits. So yeah, that's why 32-bit systems were limited to 4 gigs of RAMs for the whole thing, and yeah, sub-processors with 2 gigs of RAM. So yeah, maybe you have a 4 gigs of string. It's a, yeah, it might be tricky to serialize that. The file, especially if you say you might ask, it will be pretty big. Anyway, I reckon I am good with this. I think I got what I wanted across. I did not get to do a lot of Maya, which, not a big surprise. But, I don't know. I think this is important. Hopefully people did too. Alright. Any questions? Because if there aren't, I, for once, will actually close the stream bang on time. Because I think at this point we have been going for exactly an hour and 50 minutes. I will give you chat guys, like, and girls. Like here we use guys for both guys and girls and anything in between. I will give you, what's the delay? I think we're catching up to the delay now. Maybe another 10-15 seconds. Otherwise, this is going to be it. Going once, going twice. No man in the back with the hand up. Cool. Alright, I'm going to stop the recording. I'll be up on the stream for another minute or so just in case something comes up. But thanks everybody for watching. How do you pronounce my last name? My last name is Fragapane, which, don't worry, I mean, even Italian people struggle with it. And the amount of times they go like, oh, frangipane, like the flower. It's like, yeah, sure, I'm a precious flower. Cool. Alright, seems to have been well received. There don't seem to be any questions that are about the subject specifically. I am going to stop the recording. If you are on YouTube, thanks for watching. If you are on the stream, I'm going to be around for a couple more minutes.